You ever look at the phone in your hand or the car you drive and wonder how thousands of tiny parts can just fit together so perfectly? Well, it's not magic, it's precision engineering, and it's all built on a secret that's hiding in plain sight on just about every factory floor. So today we're going to pull back that curtain and meet the unsung heroes of manufacturing.
All right, let's dive right in. See, the biggest challenge in modern industry isn't just making one perfect thing. I mean, any skilled craftsman can do that with enough time. The real challenge, the game changer, is making millions of them, each one an exact flawless copy of the last. And that, right there, is the replication problem.
So how do you do it? Seriously, how does a factory make sure that the millionth part off the line is a perfect twin to the very first one? The scale of that problem is just staggering. But the solution? It's surprisingly elegant.
And it all comes down to these two brilliant yet simple-looking tools, the jig and the fixture. Now, they might look kind of similar, but they are the absolute heroes that solve that replication problem and, honestly, make our modern world possible.
Okay, so what's the big difference between them? At first glance, you might think they do the same thing. They both hold a part, sure, but how they do it is fundamentally different. And understanding this distinction, well, that's the key to appreciating their genius. So let's talk about the jig first. A jig has count 'em, two critical jobs. First, it holds the workpiece steady, just like you'd expect. But, and this is the important part, it also guides the cutting tool. The best way to think about it is like a stencil. You know, a stencil that both holds the paper down and guides your pencil so you draw a perfect shape every single time. It makes it almost impossible to mess up. Now, a fixture, on the other hand, is a specialist. It has one job and one job only: to securely hold the workpiece in the exact right spot. That's it. The big fancy machine, like a CNC mill, already knows precisely where to go. The fixture is basically a super strong, custom-fit vise that just says, "Hey part, you stay right here," and then lets the machine do all the work. And this table here really lays it all out nice and clear. A jig guides the tool, right? So it's usually lighter, more portable, perfect for stuff like drilling or tapping holes. A fixture, though, it has to fight against these massive cutting forces from a milling machine, so it has to be heavier, more robust, and it's always clamped down tight. It just makes sense when you see it side by side. So we know what they are, but why are they so revolutionary? The payoff, the reason these things are so important, is what they do for mass production. And their impact on manufacturing, it's almost impossible to overstate. The advantages are just huge. I mean, production speed absolutely skyrockets. Accuracy becomes so high that parts are interchangeable. That's why you can buy a replacement part for your phone and know it's going to fit perfectly. And because the tool does all the thinking, you don't need a master machinist for every single task. That lowers labor costs, makes the workplace a whole lot safer, and at the end of the day, it's why we can all afford these complex products.
But how you actually guarantee a part is held in the exact same position, down to 1/1000th of an inch, every single time. This isn't just about clamping it tight. This is about controlling physics. And engineers solve this with this beautifully elegant idea called the 3-2-1 rule. Okay, to get the rule, you first have to understand this. Any object floating in space can move in 6 different ways. It can slide forward and back, side to side, and up and down. That's 3. And it can also rotate around each of those 3 axes. Think of it like pitching, yawing, and rolling. Those are called the 6 degrees of freedom. So, here's the crucial part. For perfect, repeatable manufacturing, you can't have any of that movement, not a bit. You have to locate that part in a way that restricts all 6 of those degrees of freedom. You're aiming for total, complete stability. And here is the genius of 3-2-1. First, you rest the part on 3 points. Since any 3 points define a flat plane, that instantly locks down 3 of those movements. Then, you push it up against 2 more points on another side. That gets rid of 2 more. And finally, you push it against 1 last point on a third side, arresting that final pesky degree of freedom. 3, 2, 1. Boom! Perfect location. And this is the result. It's beautiful. With just 6 very specific points of contact, that workpiece is totally locked in space. It's perfectly positioned, completely stable, and you can put it in that exact same spot a million times in a row. It's just an incredibly smart solution, proving that perfect stability comes from precision, not just from brute force clamping. Now, of course, knowing the principle is one thing, but actually designing a great jig or fixture, that's a whole other level. It's a true craft, and it's guided by some really clever practical rules that have been perfected over decades.
And this one might be the most important rule of all. It's called foolproofing, or poke-yoke in Japanese.
It means a great design makes it physically impossible for an operator to load the part incorrectly. It only fits one way, the right way. It's brilliant because it completely eliminates a huge source of human error before it can even happen.
And beyond that, great design is all about being smart and efficient. Using quick acting clamps to cut down on loading and unloading time, keeping the tool as light as you can for easy handling. Even simple stuff like making sure there are openings for all the little metal chips and shavings to fall away, that's absolutely crucial for keeping a production line running without a hitch.
So I'll leave you with this thought. Just look around the room you're in right now. Your laptop, maybe a lamp, your chair. How many of those things exist because of a jig or a fixture? Every single mass-produced object you see is made of parts that were held, located, and machined with unbelievable precision, all thanks to these silent, invisible, and absolutely essential tools. They really are the unsung heroes of our modern world.